so here we go. We're going to start with, we've got this thing factored, and it says x plus 4 and x minus 1 over x plus 4. We had to factor the top and factor the bottom, but we were left with that. Raise your hand if you had that. Okay, good. Now, I get to teach you things like, are there any horizontal or vertical asymptotes? All right. So, we'll teach you some rules for how to find horizontal and vertical asymptotes. But today's stuff is more focused on quadratics. But I want to say, would you agree that x equals 1 is probably important? Yeah, because that makes the top 0. That's called the x-intercept. Would you agree that 4 is probably an important number to this function? Because it makes the bottom 0. That makes an asymptote. Do you remember the asymptotes in those functions that run like this, you know, up and down? Well, the vertical asymptotes come from what makes the bottom 0. All right, but today I really want to get you ready for that first 20. That's one of the things that's on the first 20. Another thing on the first 20 is this, x squared minus 3x minus 1. Would you agree that you probably can't factor that because you only have a 1 times a 1, and how are you going to make a 3? You know what I mean? If you wanted to play with it for a while, you'd figure out, I can't factor it. So my favorite saying goes, toast, can't factor it, you should, but you got to know the follow-up. What do you do to solve it if you can't factor it? Yes? Very good. Everybody write down the quadratic formula from memory. X equals negative b. I'll get you started. This is one of the first 20. You've got to know how to find the answers to a quadratic that doesn't factor. Factoring would have been so much easier if we could. Plus or minus square root b squared minus 4ac all over 2a, like that. Who had that one before I said it? Okay, cool. Now, let's actually put the numbers in. Put a little empty parenthesis where all of the variables were. I would just erase them all and then put parenthesis, 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 parenthesis. And then drop in the right number in those parentheses. Do the parentheses matter? Yes, they do. Let me just show you, for example, this one. b is negative 3. Did you know that if negative 3 is in a parenthesis and then squared, it's different than if it wasn't in the parenthesis and it was squared? You know what I mean? Like negative 3 squared compared to negative 3 in parentheses squared, they're a different answer. This one comes out negative, and this one comes out positive. So, yeah, it matters. So that's why I put parentheses in, because sometimes it matters. All right, so now we're going to drop in b there, and here's another place for b. For AC, I guess the a's are important. There's 2 of them, and the a is a 1. Not x, just 1. Okay, and then the last is the c, which is a negative 1. And then everybody simplify that all the way down, and that would be the answer to one of your first 20s, is knowing how to do that. 3 plus and minus square root. And if you know, you know. There's 2 negatives. That means you're going to add 4 to the 9 makes 13. Raise your hand if you add a 13 there. Cool. If you thought, but I thought you're supposed to subtract. Okay, but you're supposed to subtract a negative because there was 2 negatives, so that becomes plus. All right. Now, how would you enter that on Schoology? They're going to ask you for what's here. Then they're going to say what's here. And how do you type in a square root? SQRT. If you're going to type that into Schoology. And then they ask you what's here. Okay. Any questions about how we got that? It was called the quadratic formula. It's used to solve quadratics. All right. That is our first 20 skill. But now let me teach you the beginning of higher algebra, quadratics, where you're supposed to know a few things about quadratics. First off, I just need you to know a bunch of terms. If I make a parabola right there, do you get it? It's been shifted right and down? We just had a test on how to write equations for stuff like that. All right, so let's say that this is at 3 comma negative 1. Makes sense, it went right and down, okay? What's that spot called? The vertex. Everybody write vertex next to it. We need a bunch of terms here. V-E-R-T-E-X. And underneath it, I want you to write x equals negative b over 2a. That's the formula. You remember that a, b, and c thing we just did with quadratic formula? Negative b over 2a is the beginning and the end of the quadratic formula. Think about that. X equals negative b, and then there's a bunch of stuff, and then it's all over 2a, right? The beginning and the end of the quadratic formula is how you get the vertex. So if we know this equation, and we know it's a and it's b, you can get the x value of the vertex by getting negative b over 2a. All right, would you agree that this parabola would look like this? If it hasn't been stretched, it would be x minus 3 because it's 3 to the right, and then minus 1 because it's down 1. Does that make sense to you? And then do you get that you could have known the vertex was at 3, negative 1 by just looking right there? Okay. Next thing we need to know is what the heck is the name of that line that runs right down the middle of this? Axis, keep going, of symmetry is correct. That dotted line that runs right down is called the axis of symmetry. And one kid in a class one year said, I'm going to call it the axis of symmetry because it's always x equals. The asymptote, it's not an asymptote though. It's like an asymptote. It runs up and down. It's like a vertical asymptote sort of. But that's the line of symmetry. You all have one on your face. Runs right down the middle of your face. Okay? And that axis of symmetry is x equals, everybody look at our problem. X equals what? There's only one logical answer. For this parabola, what's the x equal? 3. Notice you could grab it from the vertex. Which means this right here is the x of the vertex. So that right there is the axis of symmetry line. Negative b over 2a. The beginning and the end of the quadratic formula. All right. So far, are you picking up what I'm laying down? Do you have any questions so far? Okay, next. Would you agree that this thing has x-intercepts? You see them right there, can't you? Now, how do you get the x-intercepts? By multiplying this all out and then factoring it. Factoring comes and saves the day again. All right, so let's multiply this all the way out. X minus 3 times x minus 3, and then I got to subtract 1, so that's x squared minus 6x plus 9, but minus 1. So then that's plus 8. Now, if you can factor it, you should, right? Go ahead and factor it. I'm telling you, it'll help. If it can factor, it'll really help because it'll tell you the x-intercepts. X and x. Do you guys agree it's got to be a minus and a minus? To make a positive 8, it has to be a minus and a minus. And what do you think the final two numbers are? Yes? Negative 4, negative 2. Very good. And if I can check you real quick, I'd go like that, and I go negative 2x, negative 4x makes a total of negative 6x. It worked. Sweet. All right. So then, what are the x-intercepts? Right there. 4 and 2. That's at 4. That's at 2. Now, the x-intercepts could be written with y equal to 0, so 2 comma 0 and 4 comma 0, if you want to write them as points. Now how about the y-intercept? I'm going to say another statement that it isn't used near as much as if you can factor it, you should. But it's a statement that you can repeat on the test. It's going to happen on your next test. You want to know the x-intercepts? Then you're setting y equal to 0. For the x-intercepts, you're finding out where y equals 0. Does that ring a bell? You remember solving things like that, where y equals 0? So the x-intercepts are where y is 0. What are the y-intercepts? Where x is 0. X int where y equals 0. And the y int is where what? X equals 0. So if I give you any equation, even if it's weird looking, let's say I have it factored so it's not like the normal kind where the y-intercept's just always at the end. The y-intercept is not always at the end. There. A lot of people are like, oh, the y-intercept, that's the number at the end. No, it's not. It's where x equals 0. You stick in a 0, everybody solve it, and you'll be able to know what the y-intercept was. You stick in x is 0. I'm not asking for the vertex. The vertex would have been 1, negative 4. We're not asking about the vertex. We're asking about the y-intercept. So I put in x is 0, and I get negative 1 squared, which you should know is 1. And then y equals 1 minus 4. What's 1 minus 4? Come on. Negative 3. Good. What was that? The y-intercept, which is where x equals 0. All right. Kind of intense, but you're getting a lot about parabolas here. Okay. Imagine for a moment we had that same parabola we had a second ago where it was at, the vertex was at 3 comma negative 1, and then we were able to like figure out that it goes like this. Do you agree eventually this would hit the y-axis? Now, if you could just see it on the graph, you'd just like, you know, touch that spot on Desmos and it would like the graphing software and it would be like, tell you what it was. But what if you just have an equation? Y equals x minus 9 squared plus 10. If you want the x-intercept, set what? Y equal to 0. If you want the y-intercept, you would not do that. If you want the y-intercept, you'd set x equal to 0. All right. Catherine, be back with me, please. This is really important stuff. All right, so we have a parabola, and it goes like this. What's this dotted line down here called? Say it if you know it. Axis of symmetry. Good. What's this spot here called? The vertex. What's these two spots here called? X-intercepts. What's this spot here called? The y-intercept. Okay, you got the terminology. Who remembers the equation for that little line that runs up and down? Negative b over 2a. Who remembers how to find the x-intercepts? That you get from doing what? Y equals 0. And you can factor it. Because if you factor your quadratic, you'll get those x-intercepts. And it also comes from the quadratic formula. Remember, if you can factor it, you should. So, but what if it won't factor? Because like, oh, I can't factor it. The quadratic formula gets you these two spots. How do you get the y-intercept? X equals 0. You set x equal to 0. And just from seeing an equation that's in the special form called vertex form, you should be able to tell me the vertex within 5 seconds. What's the vertex of that one? Say it if you know it. Come on. Say it out loud. Fine. I'll call on 3 people and torture them. It'll go faster if you guys just participate. All right. row 4, you're first up. What's the first part of the of the vertex?
5.
5. All right, row 5, person 3, -10. That goes there. And how come we change this to +5? Because you do the opposite. And then that's my vertex, and then the x of it says something important. Mr. Long, what's the x part of it? I know it's x equals 5, but what is it?
I don't know.
All right, look at the picture. Try again, you can do this. The x of the vertex, the only x equals thing up there, right there, you know the name for that?
Axis of symmetry.
There it is. So this part right here gives you the axis of symmetry. All right, there, you've got some review now of what quadratics are like. You got a quiz on quadratics, and we're gonna start that together so you know where the quiz is. Then we've got the timed first 20, and we're gonna finish that in class. But everybody to start with the homework, which is a Schoology quiz that I want you to open right now. Pausing. All right, Vaughn, read me the first question off the Schoology quiz.
For the graph below, identify the following. Vertex.
Vertex, stop. We'll do the vertex together right now. You're going to want to put that in a parentheses with a comma in the middle. All right. What is the vertex of that one, Vaughn?
-1, -4.
Raise your hand if you agree with him. Okay, good. We got the first part of it done. Now what's the next question?
Axis of symmetry.
And I called it the axis of symmetry. You have to say x equals. You can't just say a number. A number is not a line. That dotted line that runs through it down the middle, that's the axis of symmetry. X equals what, Vaughn?
-1.
Yep. You can always just grab it from right here. It's the x of the vertex is the axis of symmetry. All right. I think you got the idea. I think I got everybody in the quiz now. And this is the part where that one is just your homework, and you have a ton of time over the weekend to do it. You got 3 days. Very doable. And it's not even that long. Question?
For the x-intercepts, should we put them in parentheses, or should we just...
For the x-intercepts, good question. Does it say, like, how it wants you to give them? Does it say anything?
It just says enter the small value first.
Okay, let me look at it. Physically look at it. Okay, yes, x-intercepts should be entered with parentheses like this. So your x-intercepts, what do you think they are?
-3.
If it's an x-intercept, then the y is 0, right? So that's how to put in an x-intercept. You put it in parentheses, and you put it with a comma. So that's one of your answers. All right, so now I want you to set that aside. That is not a timed quiz. You can resume it later. And would you please, is the other one open yet?
No.
Okay, I will open the other Schoology quiz, which is the first 20. And you need to finish that before you go. If you have extended time with a 504 or an IEP, I will give you more time, but you have to finish before you leave today. Even if I have to hold you into the next hour. Pausing, and that'll be the end of the video for today.